next part is of the discussion is the pressure belts. So pressure belts have been pressure belts have been of two types. Pressure belts is of two types on the basis of the source of development. The pressure belts have been divided into two types. One is thermally induced pressure belts. Number two is dynamically induced pressure belts. Right, so two types of the pressure belts are there. So on the earth we find the different pressure belts. So one is 10 degree north, 10 degrees south. There is equatorial low pressure belt. Equatorial low pressure belt. Thereafter, at the 30 to 35 degree latitude, north and south, this is subtropical high pressure belt. Subtropical high pressure belt. Then after there is 52 north, 55 degree north and 50 degrees south to 55 degrees south. This is subpolar low pressure belt. Here also subpolar low pressure belt. And at the 66.5 degree north to 90 degree north and south, it is called polar high pressure belt. This is called polar high pressure belt. Now, equatorial zone, it receives vertical rays throughout the year. So temperature in this zone has been recorded high, right? Equatorial zone temperature has been recorded high. So there is a permanent high pressure zone. So this belt is low pressure center. So this is thermally induced pressure belt. Equatorial low is thermally induced pressure belt, right? In subtropical areas, the position of sun in the northern hemisphere and the southern hemisphere take place while the apparent shift of sun to the north and south is up to 23.5 degree north, that is Tropic of Cancer, 23.5 degree south, that is Tropic of Capricorn. So position of sun in the summer of northern hemisphere is on Tropic of Cancer, vertical on the Tropic of Cancer, and there is sun on the southern hemisphere on the Tropic of Capricorn in the southern hemisphere. So that is called this is apparent shift to the north, this is summer solstice, and the apparent shift to the south, there is winter solstice. Clear? So this area receives the vertical rays. This area receives the vertical rays here, right? So that the tropical region or the subtropical region receiving the vertical rays, in spite of that, or there should be low pressure because of high sun. Yes or no? The sun there is high, sun is high, so there should be low pressure, right or not? But their high pressure belt has been maintained. High pressure means what? What we discussed about the high pressure. High pressure में क्या बताया था? This is equatorial low, equatorial or the equator, 10 degree north, 10 degree south. Equatorial low. So you can find out where the areas of the world comes in this zone, right? Subtropical high, 30 degree, this is 30 degree latitude, and then 35 degree latitude. You can find out the areas of the effect. Here also, this is 30 degree latitude in the southern hemisphere and 35 degree latitude, right? So there is, the areas are under the effect of vertical rays of the sun, should be low pressure, but because of this is high pressure has been maintained. So it is dynamically induced pressure belt. Means temperature is not the reason for the development of high pressure. High pressure means what? Low temperature, right? So, but in this zone the temperature has been observed high, but in spite of that the high pressure has been developed. So, means this high pressure is developed due to the dynamic effect, right? So, this is dynamically induced high pressure belt. Clear? Then after in the subpolar areas, wind moving from the subtropical high to polar low. Wind blows always from high pressure to low pressure area. So, wind moving from the high pressure to low pressure area, high pressure to polar region, and the wind coming from the high pressure towards the subpolar areas. So, wind is moving from the subtropical high to subpolar low, and the wind coming from the polar high region, right? So, there will be temperature contrast, so that this belt is formed, subpolar low pressure belt, temperature should be high or low. Subpolar zone, temperature should be high or low. Temperature should be high or low. Low. It has the influence of polar winds. So, but there, so temperature should be low, pressure high. But here, because of the wind pattern, their pressure has been maintained low, right? Means temperature is not the reason or not the factor for the development of low pressure zones. So, again this is also dynamically induced. Dynamically induced pressure belt. Am I clear? Clear or not? So, dynamically induced pressure belt, which subpolar low, and polar high, temperature is high or low? Polar high, temperature high or low? Polar region, temperature high or low? Low. So, pressure will be low. So, this is again thermal induced. So, means we have 3 thermally induced. How many pressure belts are there then on the earth? How many pressure belts have been observed on the earth? Jaldi jaldi, fटाफट. How many pressure belts has been observed on the earth? कितना हो गया? अरे 7 हो गया ना. 3 in north, 3 in the south, 1 equatorial low, 7 pressure belt. So the 3 pressure belts, equatorial low, polar high north and polar high south, these are thermal induced pressure belt. 4 pressure belt, subpolar low and subtropical high, north and south, and the 4 are dynamically induced pressure belt, right? So, wind always blow from high pressure to low pressure areas, and the low pressure areas have, low pressure center will have convergence of wind. Am I clear? Low pressure center has convergence of wind. This is cyclogenesis. This is cyclogenesis. Clear? And high pressure has anticyclone condition, low temperature. So this is anticyclone. Right? So the wind blowing in a subtropical high pressure zone. Subtropical high pressure zone. Right? And one more important thing here is all pressure belts are migratory or shifting in nature with apparent shift of sun. With apparent shift of the sun. समझ में आ गया आप लोगों को? Right? Apparent shift of the sun means the position of sun has been shifting 23.5 degree north, 23.5 degree north in the summer season. Does the sun changes the position? Does sun changes the position or not? Sun is static. Sun does not change the position, but the revolution of earth or the position of the earth is changed in the respect of the sun. Right? So, summer solstice, winter solstice. So, it is the position of the earth is changing in the respect of the sun, revolving the sun. Right? There is no, or the sun is a static. But to make the easy explanation, we assume the earth is static and the position of sun is changing to Tropic of Cancer during the summer solstice and Tropic of Capricorn in the winter season. Right? So this is called apparent shift. Right? Apparent shift of sun to the Tropic of Cancer and Tropic of Capricorn. Clear? So there is a apparent shift of sun to the north and the south. North means Tropic of Cancer and the south means the Tropic of Capricorn. So these pressure belts have been shifting in the nature with the apparent shift of sun. So subtropical high pressure belt shifts up to 40 to 45 degree latitude north. Right? Subtropical high pressure belt shifts to the 40 to 45 degree latitude in the north during summer solstice. Am I clear? Right? And 30 to 35 degree latitude, this is the position of in the summer solstice. Right? And the pressure belt shifts to 30 to 35 during the winter solstice. This is winter solstice position. And this pressure belt in the southern hemisphere will again shift to the 40 degree to 45 degree south. Subtropical high pressure belt will shift to 40 to 45. Here, this belt will shift to 30-35 in the winter season and it will shift to the 40 to 45 during the summer. The whole mechanism of pressure belt changes north to south. समझ में आ गई? देखो, पूरा सिस्टम चेंज हो जाएगा ये. Because sun is moving to the north, this northern hemisphere will start heating. So this whole system of the belt will change to the north or will shift to the north. This pressure belt will come to 40-45. This will come to the 55 to 66. And this belt will go very close to pole, beyond the 75 to 90 degree. Right? यहाँ पे क्या होगा? This belt will come to 55, 66 and a half. This belt will come to 50, 55. This belt will come to 30, 35. This will during the summer solstice or the position of sun in the northern hemisphere. When this is the winter of northern hemisphere, so this area will be cooled, this area will be heated more. Right? The whole system will again shift to the south. This belt will come on 40-45. This will come to the beyond the 66.5. This belt, this and this belt will come to 40, 45. This will come to 30, 35. There is a complete shift to the south. This is called the seasonal shift of pressure belt. समझ में आ गई? So this is seasonal shift of pressure belt with the apparent shift of sun. It is responsible for the shift of the pressure zones on the earth. Clear? Right? Now, here the high pressure zone or the wind blows from high pressure to low pressure area. Now I am coming on the pressure belts of the word and the wind pattern. Wind blows from high pressure to low pressure area always, yes or no? देखो यहाँ पे मैं I'll discuss the 2-3 concepts all together. Wind should blow straight. Because of Coriolis, this has been deflected to the left. Wind should blow straight, but again because of Coriolis, this has been deflected to the left, blowing from the high pressure to low pressure areas. Again, right? Subtropical high pressure. High pressure means anticyclone. Wind blows from high to low. So wind, must remember, wind, name of the wind is always known by the wind comes from the direction, right? So what is the direction of wind? The wind is coming from which direction? Jaldi bolo, towards NCERT. North, east, south, west. It is coming from northeast direction. कौन सा बोलेंगे इसको? क्या बोल देंगे इसको? It is northeast wind. It is called the northeast trade. This is coming from southeast direction. This is southeast trade. Why it is called trade? So these winds are moving from northeast to southwest. Northeast to southwest. Right? Northeast to southwest. So, क्या बोल रहा था मैं? Why it is called trade? Why these winds are called trade? Why? Why? It is called trade because of monsoon pattern. Al-Masudi was an Arabian trader, Arabian geographer, who coined the term monsoon, right? Which means a mausam, right? Or means a season. So monsoon is nothing but the extension of southeast trade towards India, and there is a monsoon is a seasonal change in the pattern of the wind. So in the monsoon season, these winds have been crossing equator and then reaching to India during summers, and in the winter these winds only coming back and then reaching to the southern Indian Ocean. So there is a seasonal pattern. So these winds were favorable for sailing the boats. These winds were favorable for the sailing the boat from the Saudi Arabia to the Southeast Asia for the trade. Therefore, these winds were favorable for the sailing the boat from Southeast Asia to the East Africa for the trade. Therefore, these winds have been called trade wind. Right? Al-Masudi, that he was a person who coined the term the monsoon. Right? So they are called the Southeast trade. Clear on? So these winds are blowing in which region? Which is this region? Which is this region? Which region? Which is this region? Bolo, fast. wind is originating in the subtropical areas, they are blowing towards the equatorial, so they are passing from which region? Jaldi jaldi se. Is it not the tropical areas? Is it not the tropical region? Right or not? Can we call them the tropical winds? Right? They are the tropical winds. What is the direction of this? Northeast to southwest. So can we call this, these all winds are coming from the eastern direction or not? They are called the tropical easterlies. ये book में नहीं है, इसको याद रखना. They are tropical easterlies. So they can ask you question on the different terms, but the same is the term with the mechanism is same. Southeast trade is only the tropical easterlies which blows in the tropical region. Clear all? समझ में आ गया? What will be the temperature of the wind when they are starting from the subtropical high pressure zone? They are coming from the subtropical high. What will be the temperature here? Temperature of the wind, high or low? Relatively low, because they are coming from the high pressure zones. So this temperature will be relatively low, right? Now they are approaching towards the equatorial zone. They are crossing or they are moving in the tropical region. Tropical region is known for high temperature throughout the year almost. So when they will approach towards the equatorial zone, the temperature of the wind will increase or not? Yes or no? क्या हो जाएगा wind? The wind will become warm. So they are on. So this is 45 degree latitude. I am taking from the margin of 40 to 45 degree latitude. So these winds are coming from 40 to 45 degree latitude. So this is the summer of the southern hemisphere, and the position of the winds is high pressure in the north, then 30 to 35 there in the north, right? So this in the summer of the southern summer of the southern hemisphere, 40 to 45. Now see the location. Winds are coming from the oceans. Now they are approaching, they are blowing in the equatorial zone. So the winds will become warm or cold. Winds will be warm or cold? Certainly warm, because they are blowing in the tropical region, right? So they will gain temperature. So what will happen? They will become warm. What will be the temperature of this ocean in this latitudinal zone? Fast, warm again. It will receive the insolation. So this will become, this wind is warm and blowing over the warm ocean bodies or the water bodies. So what will be the physical state of the wind? They will gain moisture. So wind will become, क्या बन जाएगा? What will be the state of the wind? क्या हो जाएगा? Moist हो जाएगा. The wind will become moist. What is moist? Moist क्या हो जाएगा? Moist means it has presence of vapor. So what is the state of wind? So now the wind is warm and moist. So means it has moisture. So क्या बन गया? Wind has become moist. So right, so that the wind is now easterlies. इसको याद रखना देखो. The wind is easterlies. This is easterly wind or not? This is easterly wind. This is easterly wind. I am talking about the southern hemisphere. So this is continental mass and this is Indian Ocean. Indian Ocean. So the wind has been blowing over the warm sea. Right or not? Wind is warm. They will gain the moisture, so it will become moist. Clear हो गया? Now this has been reaching, they are in the coastal areas. This has been reaching to the coastal areas. Right? Now they are obstructed by the mountain or the orography. What will happen? They have been striking the against the orography, so they will rise up in the mountain against the slope of mountain. What will happen? Rainfall will happen. So there will be precipitation. समझ में आ गया? There will be precipitation. तो क्या होगा यहाँ पर? Which type of climate will develop here? कौन सा climate होगा? Fast. Which climate will develop? Moist wind, coastal areas, tropical. Humid हो जाएगा? नहीं हो जाएगा? Humid condition will prevail. Right? देखो सिंपल है एकदम, एप्लीकेशन, बट application of concept. The warm is coming from the oceans. Which wind is this? This is coming from the sea to land. What type of wind is this called? कौन सा wind बोलते हैं इसको? Onshore बोलते हैं नहीं? Onshore wind. The wind is coming from ocean to land or the sea to land. It is called the onshore winds. So onshore wind always will have moisture. याद रखना. When they are blowing over the warm sea. When they have moisture and they have been obstructed by orography, so they will certainly precipitate. Clear? किस टाइप का रेनफॉल हो गया ये? Orographic rain, right? Then after this will precipitate here. Now this wind has all precipitated. This part of the mountain is called windward side. This is called windward side. Right? It is called the windward side. So it has all precipitated here, and then now it descends over the, this is called leeward side of mountain. Windward side and the leeward side. It has all precipitated on the windward side. Now the wind will have moisture or no? Not. So moisture will gradually decrease or the wind will become warm and dry. So क्या हो जाएगा ये? Warm and dry. Now it is blowing on the continental mass. कहाँ पर आ गया? It is in the middle of the continent. Will it have moisture? No. Will it precipitate? No. Why? Moisture all have been exhausted on the windward side of the mountain. Now this is also ocean here. This is then after it is moving over the oceanic part. What type of wind is this? It is offshore now. Now it has become offshore. What is the this physical state of the wind? It is warm and dry, and the moistureless. No moisture. Absolute dry and the absolute moistureless, because it has all precipitated in the onshore of the continent or windward side of the continent or orography. Right? यहाँ पे क्या हो जाएगा? There will be prevalence of dry condition. समझ में आ गया? Will it allow any wind coming from the oceans? Yes or no? होगा. Will it allow or not? कैसे होगा? Because it is moving away from the coast, so it will obstruct whatever the wind will be approaching to the continent. They will also push those winds away from the coast. तो क्या हो गया यहाँ पर? Permanent dry condition हो गया नहीं हो गया? So this is responsible for formation of hot desert. कहाँ बन रहा है? Which region? Tropical, subtropical areas in the western margins of continent. समझ में आ गया? This is which part? Eastern margins of continent. This is the western margins of continent. So trade wind also one of the key factor for the development of the hot deserts in the western part of the continents in tropical and subtropical areas. Clear all? कहाँ से बन गया देखो? अब यहाँ पे आप just apply this concept on the map. Southeast trade, this is here is Drakensberg range in the South Africa. Southeast trade have been obstructed by Drakensberg. So eastern part of South Africa has moist climate because of onshore trade winds. Which trade wind? Southeast trade. Now trade wind has been moving there to the west. So there is about 50 to 100 centimeter rain. Western part also has some rain there in this west part on the Weld range. There is also 50 centimeter rain. So when the wind blows there in the coastal part or the interior of the continents, so there is this is dry condition prevails. Which desert is this? Which desert? Here. कौन सा है? Kalahari desert, Botswana. Then wind has been moving away from the coast. तो ये कौन सा desert बन गया? Which desert is this? Namib desert. Namib desert. समझ में आए? Is the trade wind not responsible for the formation of the deserts in the interior of the continent also? Yes or no? Because they are absolutely dry, free of precipitation, no moisture. So what the precipitation occur? Only 10 centimeter, 15 centimeter, 20 centimeter, which is not sufficient for the growth of plant. In this atmospheric condition, means in this hot and dry condition, that is not sufficient for the growth of the plant. Then the wind is becoming offshore. Then offshore means it is moving away from the coast. क्या हो जाएगा यहाँ पर? It will take away all the moisture, or it will push away all the moisture reaching, or the wind reaching to the coastal areas. So that will develop the permanent dry condition in the coastal belt. Formation of which desert? Here is Namib Desert in Africa. Right? Clear हो गया? समझ में आ नहीं आया? अभी देख लो यहाँ पर. Eastern coast of Australia also has moist condition. This is which range? Great Dividing Range. It is now offshore winds or the dry winds prevailing over the western and the central part of Australia. This is Tanami Desert, Simpson Desert, Gibson Desert, Great Victoria Desert. है नहीं? Western part, Great Sandy Desert. Right? So all desert is because of why? All desert is because of trade wind. Dry, hot trade wind obstructed by orography on the coastal margins. Right? So onshore trade winds are precipitating on the eastern margins of continent, and over the continental masses in the western part of the continents have been developing the hot and dry desert in the which region? कौन सा area है? This is Tropic of Cancer. Sorry, this is Tropic of Cancer. Sorry, Capricorn. Which region? So here is a formation of desert in the tropical, subtropical areas. समझ में आ गया? So trade wind is responsible for the formation of hot desert on the margins of continent as well as in the interior part of the continent, because they are hot and dry. Right? Similarly, driest desert of the world, what is it? Again offshore winds. Clear? Will these winds not reach there? Same. Right? But there is no desert in the western part of Brazil. Reason for? Why? Because these winds are merging with the convection process over the Amazon basin. Right? They are not merging with the offshore, and they are merging with the convection process over the Amazon basin. Clear? समझ में आ गया इतना? Then after northern part में आ जाओ. This northeast trade, again they are onshore. So what will happen? There will be huge precipitation. Here is, this is there in the this is 45 degree latitude again. If I take this part of the 45 degree latitude and the 40 degree latitude, so these winds will blow like this. Right? Again onshore and the offshore. This is, now see the desert of Rajasthan. Again it is in the effect of offshore. See this is Iranian desert, this is Saudi Arabian desert, entire Sahara desert. So they are under the effect of, again, offshore trade. Right? This is Sonoran desert. Right? This is also California desert. Again offshore trade wind. समझ में आ गया? So trade winds are responsible for the formation of the hot deserts in the western part of the continents. Thereafter they are merging in, or they are converging in the equatorial zone. तो क्या होगा ये? They will converge. What the pressure belt there in the equatorial zone? It is low pressure. So wind will converge along the low pressure center. So there is a convergence of wind. So this over the low pressure center, there is a convergence and rising. So it will lift up in atmosphere. Okay, abhi isme dekh lo. Here I am telling you this concept of precipitation. So the low pressure areas, the winds are converging. So which wind is this? It is what we discussed in the yesterday's class. The wind which are converging are dry. But if these winds are moist, right, moist, they will have moisture. So then they have been rising up in the atmosphere. Chalo isko pehle dry wala hi le lo. If wind is dry, no moisture is there, right? So they have been rising. Temperature of the air is, temperature is high, but about 45 degrees Celsius temperature. So when they have been rising up in the atmosphere, so they will release the heat. So they will become relatively, they will in the process of rising, they will become cool. And when they are rising up, so they release the heat, right? And the temperature has been decreasing at the rate of 9 degrees Celsius to 10 degrees Celsius per kilometer. Of which wind? Hot and dry. So this is hot and dry wind. So they have been rising up. They have been rising. So temperature decreases at this rate. So they will continue rising until they reach to the temperature of atmosphere. So these winds are light, more warm, and they have been rising up in the atmosphere. So temperature decreases at the rate of 9 to 10 degrees Celsius. So this is called dry adiabatic lapse rate. समझ में आ गया? Dry adiabatic lapse rate is what? Dry adiabatic lapse rate is the decrease of temperature of hot and dry wind in the process of, which process is there? What is this process? Jaldi. Hey, no, the process, that is a adiabatic is a rate of reduce in the temperature or decrease in the temperature. What is this process of? क्या प्रोसेस है? What is this process called? अरे कन्वेक्शन नहीं है ये, कन्वेक्शन प्रोसेस है ना, सिंपल. In the process of convection, the air when it is rising up, this is convection process. In the process of convection, the temperature of the air is decreasing, right? And it is rising in the atmosphere. So there the contact with the surface has been disappeared. So air will gradually become cool. It will release the heat which is containing from the surface. So it will gradually release the heat and will become cool while in the process of the ascending. So this process is called convection process, and in the convection process the air becomes cool, right? And it continues rising until it reaches the temperature of atmosphere and the temperature of air. Precipitation होगा यहाँ पर नहीं होगा? Will the precipitation occur here? Yes or no? Moisture is absent, so the precipitation will be absent. और क्या होगा precipitation में? The precipitation will be like the drizzling, very minute. So this air will be saturated up in the atmosphere. So there will be formation of the patchy cloud which will have this isolated moisture. So it will be responsible for the formation of patchy cloud. क्या बोलते हैं इसको? This is called the cirrus cloud. Cirrus cloud. When the air has been saturated over the higher altitude, it is called, or it is responsible for the formation of cirrus cloud. So cirrus clouds are the high altitudinal cloud. So precipitation will occur, yes or no? These clouds has very least moisture. So precipitation either will be in the form of drizzle. What is drizzle then? The tiny droplets of the water falling on the surface in the effect of the gravity. So drizzling will happen, but this drizzling will be very tiny size of droplets which may also flow with the water, right? Which may also flow with the wind. They will be so lighter, so tiny, so they can also, or the water droplets may also flow with the wind. And then when they are falling, the temperature of the surface is so high, they have been re-evaporated in the atmosphere. So they do not have any of the significance on the surface water. No contribution in the water bodies on the surface, right? So this has been saturated. This is called the dry adiabatic lapse rate. समझ में आ गया, right? अभी यहाँ पर देखो, इसको चेंज कर दो now. The wind has been moving towards the low pressure areas. So this wind it is moist. Now over an area, the wind has been moving towards the low pressure center is called the moist wind. Clear? When the moist wind has been moving towards the low pressure area, it also will rise, because low pressure is a convergence. Over the convergence, over the low pressure area, the wind has to lift up in any condition or irrespective of the temperature. Because all the winds have been converging, they do not have any of the space to move in any of the area. So they must have to converge and lift up in the atmosphere. So they have been rising up in the atmosphere. क्या होगा? Again convection process is happening. But now this time the nature of the wind is different. The rising column of air, now it is moist. So here temperature will be decreasing at the same rate or not? Temperature will decrease at the same rate or not? Yes or no? No. Why? Because the temperature of air will be more or less. In the moist air, the temperature of the wind will be high or low? Relatively low. Reason for it has moisture. So that when the air rises up, so the convection process it happens. So there is a decrease of temperature at the rate of 4 degrees Celsius to 5 degrees Celsius per kilometer. So then air has been lifting and the temperature is relatively lesser. So air will be saturated lower height or higher height. This air is rising with the moisture. So there it is release of heat. So air will be saturated or cooled over the lower height. So then there will be rising, moisture content will be present and there will be formation of clouds. Because it has moisture, so there will be formation of the vertical clouds. This is called cumulus cloud. This is called cumulus clouds. C-U-M-U-L-U-S, cumulus clouds. Right? So these cumulus clouds have been formed by vertical ascending or by the convection process. But the air should have moisture. Now it is rising up. So then it has been further rising. Now it has reached to the point of saturation. Saturation क्या होता है? Saturation is the point where the air is not able to hold the moisture or maximum capacity of holding the moisture. बारिश होगा यहाँ पर? बारिश होगा नहीं होगा? नहीं होगा. क्यों नहीं होगा? So this is saturation is a point where the air has a moisture holding capacity. And if the air has been further lifted up, that goes beyond the saturation point. So beyond this saturation point, there will be precipitation. So then, if the air has been further lifted up from the point of saturation, there will be precipitation. क्या rainfall बोलते हैं इसको? What type of rainfall we call it? What type of rainfall? The nature of rainfall will be torrential. Here will be torrential rain. Torrential means short duration, heavy precipitation or rainfall. That is called the torrential rain. कम समय में बहुत ज्यादा बारिश होगा, right? That is torrential. So torrential rainfall में क्या कर रहे हैं? तो rainfall तो nature हो गया है, type क्या हो गया? What is this process? What is this process? Convection. तो rainfall क्या हो गया? कन्वेक्शन हो गया, दिस इज कॉल्ड द कन्वेक्शनल रेन. सो कन्वेक्शनल रेन कहां पर होगा? वेयर द कन्वेक्शनल रेनफॉल विल अकर? Everywhere, tropical area only. The rainfall, the convectional rainfall occurs in the tropical areas only. Yes or no? कहां पर? टेम्परेट एरिया में कन्वेक्शनल होगा, पोलर में कन्वेक्शनल होगा, है नहीं होगा. सो दिस इज द इन द सब ट्रॉपिकल एरियाज आल्सो हैज ए कन्वेक्शनल रेन. देखो जहां भी लो प्रेशर होगा ना, where there is a low pressure and the convergence of wind is there, there will be convectional rain. Anywhere on the earth there is a low pressure and convection and the ascending of wind, there will be a convectional rainfall. Clear all? Right? So there will be a convectional rainfall. Am I clear? Yes, am I clear? Then after. So there, now you tell me how it is different than the normal lapse rate. This is called adiabatic lapse rate, right? Dry adiabatic. अच्छा, यहाँ पे जो temperature decrease हो रहा है ना, this the decrease of temperature 4 to 5 degrees Celsius. This is called wet adiabatic lapse rate. This is called wet adiabatic lapse rate. लैप्स रेट का मतलब क्या हो गया? व्हाट डज इट मीन द लैप्स रेट? डिक्रीज ऑफ टेम्परेचर विद इंक्रीजिंग द हाइट, राइट? अब यहां पे क्या हो रहा है? हाउ डज इट हाउ द एडियाबेटिक लैप्स रेट डिफर्स द नॉर्मल लैप्स रेट? बोलो, हाउ एडियाबेटिक लैप्स रेट डिफर्स देन द नॉर्मल लैप्स रेट? जल्दी जल्दी, क्या डिफरेंस है नॉर्मल लैप्स रेट और एडियाबेटिक लैप्स रेट में? यहीं से बेसिक कॉन्सेप्ट है, यहीं से क्वेश्चन बना देगा, किसी का दिमाग घूमेगा तो. हाउ द नॉर्मल लैप्स रेट डिफर्स द एडियाबेटिक लैप्स रेट? देखो सिंपल सा है. Normal lapse rate is the decrease of temperature of the parcel of air or the static air in the different pockets. Different pockets means in the different altitude. From 1000 height to the 2000 meter height. So there is a one pocket of the air. So from this air, this pocket to this air, this pocket, temperature is decreasing. Air is stable or unstable? Stable air. Again from here to this pocket, again temperature is decreasing. Again from this pocket, temperature is decreasing. So there air of the stable air, temperature of the stable air in the respective pockets at different altitude is decrease of temperature in the normal lapse rate. समझ में आ गया? But the adiabatic lapse rate, there is a ascending column of air. Temperature will decrease with the rising or the ascending of the air. Here temperature of air is decreasing when air is rising. So this is the difference, that the parcel of air which is rising up in the atmosphere, the temperature of the air has been decreased in the convection process. Right? Clear? Dry adiabatic lapse rate or wet adiabatic lapse rate. समझ में आ गया? Right? Now see one more. When the air is rising, temperature is decreasing. Again the same way, same process, when the air will subside, temperature will increase or decrease? Temperature will increase. Why? Surface temperature is more in comparison to atmospheric temperature. Getting it? Clear हो गया? अब यहां से air is rising, the moist air is rising up in the atmosphere, and there in the atmosphere the temperature is warm or cool? Atmospheric temperature is less, the warm and moist air is rising up. तो क्या होगा इससे? The different air charges are colliding with each other. This is the cool air charge, this is the warm and moist air charge. When they are reaching in their atmosphere, so this will try to inject or try to inject in these areas of the cool air, क्या होगा? It will obstruct it, it will inject, it will obstruct it, तो क्या हो गया? What will happen then? Thundering. Atmospheric disturbance हो गया नहीं हो गया? So therefore there will be thundering, lightning and the heavy precipitation then. So that is a disturbance in the atmosphere. So this is all the phenomena of the weather condition. Where it is happening all? Where this all phenomena is happening? कहाँ पर हो रहा है? Troposphere में. Simple, right? चलिए. So this is all the adiabatic lapses. So precipitation will occur here. Which precipitation? Convectional rain, right? Torrential मत लिखना. Torrential कहीं भी हो सकता है, किसी भी फॉर्म में हो सकता है. Torrential means heavy amount of downfall in the short period of time. वो किसी में भी हो सकता है. Clear? चलिए. So this is low pressure and the convection process is rising, is responsible for the heavy precipitation. हाँ बोलो. हाँ. हाँ 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 no, atmosphere not adding. This is the air is rising, the heat of the air is released. It is not injection of the temperature herein. The air is rising, the heat of the air is released, so the temperature is decreasing. Why it is releasing? Because there is no contact or no source of heat now. So as it will rise, so it will release the heat. It will also become lighter then. It will become also cool. So it will try to match with the atmospheric temperature. So then until it is matching the atmospheric temperature, so it will keep rising, releasing the heat, again rising, again releasing the heat, again rising. So it will reach to the height where the temperature matches. हाँ, अरे तो moist तो temperature भी तो है ना उसके अंदर. Air has been moist air is reaching on the low pressure area. Low pressure area means what? High temperature. So it has to rise up. Where? Why not? See, it is the wind which has been converging from all the sides. Low pressure means the winds are converging from all the sides. The wind which is converging here, it may not be the same of the moist condition. The wind which is converging here, it will be moist and it will converge and rise up. There is no other way. It has no other scope because low pressure is a convergence. So this wind are coming from all the directions. So they have no options. Take example of monsoon, a simple mechanism in the monsoon. क्या होता है देखो, northern part of India excessively heated, right? So there is what condition? What condition is there? Low pressure, excessive high temperature, low pressure center. Wind are coming from ocean and the seas. किस type का wind है ये? Moist है. Monsoon means moist, coming from the ocean. This is the onshore winds. Coming from ocean, they have moisture. When they are reaching over the low pressure area, they are tend to rise up. There is no other way, right? When they have been obstructed by the mountains, they are rising along the slope of mountain. So they are forcing up to rise. When there is no mountains over the entire Gangetic plain, northwest part of India, they have been reaching and the forced to rise, right? When they will rise, what happens? Thundering होता नहीं होता, lightning होता है ना? That is the process same. It is rising, and then you will find a very dark cloud is formed. Dark cloud means what? The air has excessive moisture. Then there is a rainfall is continuous. कभी कभी देखा होगा आपने मॉनसून टाइम पे सारा ओल्ड राजनगर भर जाता है पानी से. 2 घंटा 3 घंटा continuous बारिश and heavy downpour. Reason for this heavy moisture wind which has reached to the high temperature areas, there will be a heavy precipitation. जितना ज्यादा गर्मी होगा उतना ज्यादा बारिश होगा, याद रखो. More of the temperature, more the precipitation. Because this high temperature act as a heat engine for the wind movement. pressure gradient force will be high. Yes or no? Then there will be movement of wind. Simple. High to low pressure area. Simple. If the wind is moving with the moisture, there will be precipitation. If the wind is not moving with the moisture, there will be simple Aandhi, dust storms. Right? So, this is the difference in the adiabatic rate. Normal lapse rate is, the normal lapse rate is a decrease of temperature of the pockets of air with a different altitude. But they are in the same in the different pockets of the altitude, or there the air is rising, or the column of the air is rising. So, then temperature of the air is decreasing. So, this is the dynamic decrease of the air when it is rising, and there is a gain of the temperature when it is subsiding. Right, when it will come in the contact with the air. Means suppose here temperature of the atmosphere is what? Cool. It is coming on the 2000 meters. So, here temperature will be relatively more. Here temperature is more. So, there will be injection of heat in the air. So, it will become gradually warm when it will subside. So, these winds, आपको ये mechanism समझ में आ गया? Then all the mechanism is very easy. अच्छा, इसके साथ में एक और समझ लो, नहीं तो देखो, इसको मैप को अपन हटा देते हैं, अभी हो गया इसका काम. So now see this another concept with that, then you will understand everything. So this low pressure areas, there is a convergence and rising. अब यहाँ क्या बनेगा? There wind will become cool. Cool means high pressure. High pressure means anticyclone, divergence. So it will diverge. So this will become cool and will subside on the surface. On the surface, तो क्या होगा यहाँ पर? Surface will, what will happen? There will be calm. Why calm? Subsiding down. So this will be, there will be, the wind will compress the air to reach on the surface, right? So what will happen? High pressure will be formed or not? Right? So what type of, it is thermally induced or dynamically induced? It is dynamically induced. Reason for the high pressure is formed because of subsiding wind system or subsiding air current. तो क्या हो गया यहाँ पर? This column of air has subsided. Now it has reached on the high pressure area. Another column of air has been subsiding. तो क्या करेगा यहाँ पर इसको? This column of air, one column has reached to the 1. This is now replaced by the 2. Now it is coming to the 3. The 2 has been, and the 2 has, and this 3 has been forcing the 2 to reach on the surface. तो क्या करेगा? What will happen then? The 3 parcel of the column of the air, it is compressing the 2 to reach on the surface. Then what the 2 will do? 2 will compress it, 2 will force it to move away. तो क्या करेगा ये? It will start moving in the areas outside. तो क्या बन गया ये? What is it? Anticyclone. This is anticyclone. This is, ये क्या है? Cyclone. समझ में आ गया? Low pressure convergence is cyclogenesis. Yes or no? And this is anticyclogenesis. So यहाँ पे condition कैसा रहेगा? Because dry air is subsiding, so this will be calm, dry, the stable atmosphere or no disturbance, no atmospheric instability or stable atmosphere will prevail. समझ में आ गया? Clear? अभी क्या हुआ? यहाँ पर क्या हो गया? एंटीसाइक्लोजेनेसिस हो गया. अगेन दिस पार्सल ऑफ द विंड विल गो टू लो प्रेशर एरिया. This cycle is permanent or not? Yes or no? This cycle is permanent or not? There is continuous rise, divergence, subsidence. Again there is a convergence, again rising, again divergence, again subsidence. So this cycle is become permanent. क्या बोल गया हमने इसको? This is a wind circulation. This is wind circulation or wind cell. Clear everybody? Wind circulation or the wind cell. बोलिए, समझ में आ रहा है नहीं? वैल्यू एडिशन हो रहा है, जो भी आपने पढ़ा है पहले. कहां से पढ़ा है आपने? जीएस खुद से पढ़ा है, कहीं से पढ़ा है आपने? सेवरल मतलब इतना सारा मैं कॉन्टिन्यूसली. ओके ओके. आपने पढ़ा कहीं? नहीं, खुद से पढ़ा है आपने. सेल्फ स्टडी वाजीराम. ओके. वैल्यू एडिशन हो रहा है ना? ठीक है, चलो. सो दैट देयर दिस विंड, दिस इज कॉल्ड द wind circulation, right? So now see, the wind has been converging on the low pressure in equatorial zone. So therefore there is rising of the wind. अब ये जो ओशन से आया, जो हमने बात किया था, wind is coming from the Indian oceans, Atlantic Ocean, Pacific Ocean, तो उसमें क्या होगा? मॉइस्चर होगा, नहीं होगा? They will have moisture. So when they will converge, they will rise up. कैसा है? Wind is, these are warm, this is also warm, which are blowing over the ocean bodies, right? They have moisture, so they will rise up. When they are rising, so the moisture they already have, the cloud formation will be there or not? So there is a cloud formation again. कौन सा cloud बनेगा? Cumulus cloud, right? So there will be precipitation. क्या हो जाएगा यहाँ पर? Which type of rainfall? Convectional rain. So then it is rising up again, it will become cool and high pressure will be formed here. तो क्या हो गया? एंटीसाइक्लोनिक हो गया, नहीं हो गया? Right? Now these winds will move towards the subtropical areas. Right? अभी देखो. Now see here. These winds are coming from subtropical high to equatorial low. So listen everybody here. These winds are coming from subtropical high to equatorial low. Right? They are rising. Again diverging, they are going towards the subtropical high again. Can we call this as atmospheric anti-trade? This is trade wind, which is going from subtropical high to equatorial low. They are rising, again going towards the subtropical high. Can we call them the atmospheric anti-trade? Yes or no? So they are called the atmospheric anti-trade. This is anti-trade wind, atmospheric anti-trade. समझ में आ गई? अभी क्या है? With these winds will cool down or not? These winds will cool down, yes or no? तो क्या हुआ? These winds will subside. अब subsidence में क्या हो रहा है? What is this happening in the subsidence? The air will gain relative temperature, but there the temperature will be relatively lesser, but here it will create the high pressure zone. This high pressure zone is a anticyclone. समझ में आ गया? Anticyclone. So there it comes, it completes a circulation of the wind. So where this complete circulation is taking place? Where this complete circulation is taking place? In the tropical areas. So in the tropical areas, so this circulation is happening, so that, can we call this as a tropical cell? So this whole areas has been taking place in the tropical region. So can we call this a tropical cell? Yes or no? It is called a tropical cell. This is called tropical cell. Right? It was discovered by Halley. Sorry, Hadley's. It was discovered by Hadley. So this is called Hadley cell. Hell is there in the Indian monsoon, classical theory. So this is called the Hadley cell, right? आपको कहीं से भी पूछ लेगा अभी हेडली सेल और ट्रॉपिकल सेल दोनों एक ही है, राइट? समझ में आ गया? अच्छा, मॉनसून से मॉनसून में क्या है? तो इज इट कनेक्टेड विद द मॉनसून? यस और नो? हाउ इज इट कनेक्टेड विद द मॉनसून और नॉट? Hadley cell is connected with the monsoon or not? Certainly yes. Why? Because all the trade winds are reaching there in the Indian subcontinent and then they converging and again rising, the convection process is taking place. This is rising again subsiding there in the Indian Ocean, again moving towards the India. So this tropical circulation there which is taking place over the India also the part of the Hadley cell circulation. समझ में आ गया? मुश्किल तो नहीं है कुछ, easy है सारा. So that this is called the Hadley cell. Again यहाँ पे high pressure है, so this is moving towards the subpolar areas. There because of Coriolis it moves to the east. So what is the direction of the wind now? Wind direction is southwest to northeast. So can we call them exactly the westerlies, as we have called them the tropical easterlies? So they are called the westerlies. So they are westerlies. They are called westerlies. Clear? Abhi these westerlies, because of frictional effect and this while subsiding they have gained temperature, so they have become warm or not? So they are warm westerlies, right? So then again when they have reached over the areas, just a minute. So westerlies, now westerlies, I am just making this here the rough map here, this subtropical high, and they are moving towards the east. This is warm westerlies and they are reaching over the western part of Europe. Which ocean is this? Atlantic Ocean. So these westerlies blows over the warm ocean current. Which ocean current? Which ocean current? Ocean current in the northern Atlantic Ocean. Atlantic drift, North Atlantic drift, warm. So this westerlies is blowing over the warm North Atlantic drift. क्या होगा? What will happen? They will gain moisture from there or not? They will have the favorable condition or the favorable situation for gaining the moisture. Yes or no? So they will become what type of wind? They will become what type of wind? Jaldi, fast. What type of wind they will become? Onshore तो होगा ही. कैसा wind हो जाएगा? Physical state कैसा होगा wind का? Moist होगा नहीं होगा? Simple. Warm है तो warm water पे blow हो रहा तो moist हो जाएगा. It will gain moisture. Favorable condition for the supplying the moisture. So this wind has become warm, westerlies and the moist. कितना बड़ा ओशियन है? कहां से जा रही है? The coast of USA or the Canada to the west coast of Europe. This large area or the large distance has been covered by the wind between the two continental masses. So they have the scope of abundant gain of the moisture. तो क्या हो गया? Moist हो जाएगा. So then they reach to the Western Europe, right? They have been obstructed by these few mountains. Rainfall करेगा नहीं करेगा, right? So there will be precipitation. Then after, another parcel of wind is surfacial winds are coming. They are from the polar areas. This is called polar easterlies. Coriolis force deflecting to the right. So this is called the easterlies, polar easterlies. It is warm or cold? This is warm or cold? Simply cold, because it is coming from the cold surface. Now there, from this 40-degree latitude, the wind has been moving towards the subpolar region, and from the 90-degree latitude, the wind has been moving towards the subpolar region. So this is cold, dense, heavy, moisture इसमें होगा नहीं होगा, moisture and dry, no moisture. This is warm, moist, light, right? So that they will converge along 50-degree to 55-degree north latitude or in both the hemispheres. So क्या होगा? This warm and cold, they will converge. So this situation, it is called front. समझ में आ गया? हाँ हाँ. It is dry, na? It is heavier, na? It is heavier because of its temperature. It is heavy because of its temperature. The cold wind always dense and the heavier, so they remains over the surface only. They blow along the surface only because they are heavy and dense because of temperature, not because of moisture. Right? Here the warm and moist air is there. So they have been, before mixing of two air masses means the two different or the two contrast air mass. This is called the front. Then they have been moving towards the, or they are converging along the 50 to 55-degree latitude. That zone before mixing of two air mass is called the front. So then warm air has been forced to rise up. Who is forcing? This cold air is maintaining this state or of its position or along the surface, and then for the warm has been rising up over in the atmosphere. So क्या होगा यहाँ पर? There will be formation of clouds like this, right? The winds here, the pressure belt will be bent towards the polar areas. So there will be curvature shape of the pressure belts will develop. Here, pressure belts will develop like this. Subpolar low pressure belt. This is warm, and this is cold. Here cold will come. Here cold will come. Here cold will come. Am I clear? So this whole zone is called the frontal. So there is a formation of front. So if we draw this cross section, so this is this way, the front has been formed. यहाँ पे क्या होगा? इधर में on this side there will be low pressure. On the warm sector side there will be low pressure. There will be low pressure here. There will be low pressure here. Right? So this type of this structure will develop. This is called warm sector. This is called cold sector. Means cold is more dominated. That is called the cold sector. Warm is more dominated. So this is called the warm sector. Rainfall कहाँ पे ज़्यादा होगा? है? Warm side में ज़्यादा होगा, cold side में ज़्यादा होगा. Convection होगा, convection rainfall होगा. कौन सा rainfall होगा यहाँ पर? This is the frontal situation, and this frontal situation there has been the rising of warm air. So there will be convection process, but in the frontal situation, the warm air will be rising up along the front. So this is called frontal rain. It is called the frontal rain. developing the low pressure areas. So then the warm air will precipitate here, and also the sum of the precipitation will happen here. So there will be cloud formation. कौन सा cloud बनेगा यहाँ पर? Which cloud? देखो यहाँ पर बनेगा, ये here will be nimbostratus cloud, or it is called the stratonimbus. Stratonimbus. Here will be cumulonimbus. Because warm will be more rising vertically in the warm and cold areas. Here the warm will be gradually entering in the cold areas, but there will be greater contrast in this sector, right? There will be convection, there will be horizontal expansion of the cloud. Clear? समझ में आ गया? So what the temperature decrease will take place here? Temperature decrease क्या होगा यहाँ पर इस एरिया में? Wet adiabatic rate, decrease of temperature with the wet adiabatic rate. Where the warm will enter, this will be low pressure areas, right? So there is a convergence of warm and cold. So where the warm will enter, there will be low pressure center. So this low pressure has been developed because of dynamic effect, right? And the stage will come when the warm will be completely lifted up in the atmosphere. So they will be completely occupying of the warm areas, warm air, and the cold will enter in the areas of warm. तो क्या होगा ये? There will be calm, stable weather will develop or will be stabilized. Then the precipitation will become absent, right? तो क्या हो गया? Frontal situation. So same here, they have been low pressure area, they are rising and then subsiding on the poles. This is rising again subsiding on the subtropical high pressure center. This is called Ferrel cell. So this cell is developing in the temperate zone. So we call it as a temperate cell also. This is called polar cell. So same there in the southern hemisphere also. So there will be high again. So this is Ferrel cell, this is polar cell. Am I clear? Clear? Right. So this way, there are the 3 cells in the northern hemisphere, 3 cells in the southern hemisphere has been formed. This is called tri-meridional circulation. Tri-meridional circulation. Tri-meridional circulation. Clear? अभी देखो, this is tropopause. This is tropopause. All these phenomena are happening in the troposphere only. So here the height of troposphere is more because of convection. Here the height of the troposphere is less because of subsidence of air. So here is height of the troposphere is only 8 km. Here the height is about 16 km. समझ में आ गया क्यों है? Why this height is differing in the troposphere over the equator and the polar areas. Clear? बोलो, कोई डाउट? Anybody? समझ में आ गया? चलिए. So there is this is tri-meridional circulation. किसी को डाउट? आपको डाउट? क्लियर हो गया? अभी ये बताइए, these all winds are surfacial winds or atmospheric winds? So winds have been classified into three types. One, it is called surfacial, so one it is called the yes, it is permanent wind. This is also called planetary wind. Planetary winds, right? They are called the permanent because they blow in fixed direction throughout the year. That is called permanent wind, right? And they are called planetary wind. They blow around the globe, right? They blow around the globe. Then after it is called seasonal winds, or it is also called periodical winds. Periodical winds. So seasonal winds, periodical winds are those which are blowing or which blow in a particular direction in particular time period or certain time period, and they change their direction. The direction of the wind, changes with season. Direction of wind changes with the season, right? Then after, there are local winds. So local winds, they originate due to regional or local thermal or atmospheric conditions. Local and atmospheric condition. Am I clear? समझ में आ गई? Local winds. So there are best example of this is Loo in India, Chinook, USA or North America, we call it completely North America. So this Chinook is also called snow eater. Snow eater. Why it is called snow eater? It blows over the Mississippian plain. It is responsible for melting the snow in the winter season, or making or it is responsible for making this plain snow free, or it melts the snow faster in the winter season. So therefore it is called the snow eater over the Mississippian plain in entire North America. Southern part of Canada and northern part of are entirely the North America. Sorry, USA. Right? So this is all about the wind pattern, right? So next topic we have there in the discussion, right? ये हो गया wind pattern हो गया, pressure belts हो गया, global self circulation हो गया, land breeze, sea breeze phenomena you have understood. Land breeze, sea breeze, wind coming from the sea to onshore, offshore, simple. Onshore wind is ocean wind. Onshore wind is sea breeze coming from sea. Onshore wind is sea breeze. The different names, right? Mechanism is same. When the wind is coming from the, that is correct. So this is a diurnal shift. देखो इसको समझ लो नहीं तो. There is a very local phenomena, sea breeze, land breeze, but the mechanism is same. Over the coastal areas, this land receives or absorbs more heat during the day because it penetrates up to 2 meter and this penetrates up to 200 meter. This is called photic zone. It is called the photic zone, right? So here temperature will rise faster. Here during the daytime, temperature will be rising faster because it absorbs more amount of insolation. Here it is penetrating up to 200 meter, so there relatively low temperature will be recorded. Pressure will be high or low? Pressure low. Here pressure high. So high will be absolute high or relative high? Pressure will be absolute high or relative high? Relative. They are in the same latitudinal zone. For example, if I say in the summer season of there in the southern India, Bay of Bengal and the land, they have the same amount of, they have the same insolation, right? But they have been heated with a different rate. Yes or no? Same insolation, so same amount of insolation reaching there on the surface of the water as well as on the land. But they have been heated with different rate. Correct or not? Reason for the land absorbs more heat, the sunlight penetrates up to 200 meter, so the rate of heating will be slow. So there will be a relative high pressure on the land, relative high pressure on the ocean bodies and the low pressure on the land, right? So this water will be heated slow. So wind blows high pressure to low pressure areas. Then there is a movement of wind. Yes or no? Wind is coming from sea to land. क्या बोलेंगे इसको? Sea breeze, simple, right? And in the other condition then, so there will be rising of the air, divergence, it will subside on the oceans, but this subsidence will be very weak. Subsidence will be weak, right? It will not be so strong. But there in this in the night time, so by the time or completely the whole day, the water has been heated. So this rate of there the land has been heated up to, or they absorb the heat. तो क्या होगा यहाँ पर? Terrestrial radiation will happen or not? Terrestrial radiation. The rate of heating is equal to the rate of cooling, right? The faster the land has heated, the faster it will be cooled. तो क्या हो गया? Temperature क्या हो गया? Low. Pressure high. But here on the water, this has heated completely in the whole day. So rate of heating is slow. So rate of cooling also will be slow. So their temperature will be relatively found higher. Pressure, wind blows high pressure to low pressure area. So the wind will be moving from land to sea. क्या बोल दिया इसको? This is land breeze. Simple, right? So land breeze, sea breeze, can we call this is onshore wind? During the day winds are onshore. तो क्या होगा? कभी भी आप coastal areas में जाओगे ना, you will find a very good breeze come from the sea during the day. In the night, there the wind movement is opposite. In coastal areas, the fishermen never go for fishing in the night. Reason for? These breeze, they push them into the deep seas, right? These land breeze, they pushes them into the deep seas. They go for fishing in the early hours in the morning. They will go for fishing there in the 4 o'clock in the morning. So with the help of these breeze, so they have been going to the sea and they return back, right? So this is the effect of this, the winds blow. So can we call them the offshore winds? Yes or no? Clear हो गया? समझ में आ गया नहीं आया? Right? So this is the sea breeze land breeze phenomena. चलिए नेक्स्ट वी कम ऑन द एयर मासेस. कितना टाइप का रेनफॉल हमने पढ़ लिया? हाउ मेनी टाइप्स ऑफ रेनफॉल? कितने टाइप का रेनफॉल होता है? हाउ मेनी टाइप्स ऑफ रेनफॉल्स आर देयर? आपने कौन कौन सा रेनफॉल पढ़ा है ये बताओ. 2 टाइप्स है. आपने पहले कौन सा रेनफॉल पढ़ा है? किस किस टाइप का? बोली. हाउ मेनी टाइप्स ऑफ रेनफॉल यू हैव स्टडीड? नहीं पढ़ा? पढ़ा तो होगा. तो टाइप्स ऑफ रेनफॉल कितना टाइप का होता है? कन्वेक्शनल होता है नहीं होता? कन्वेक्शनल रेन, यस और नो? नंबर 2 ओरोग्राफिक रेन. नंबर 3 फ्रंटल रेन. यही होता ना? यस और नो? एनसीईआरटी में दिया है ये तीनों. फ्रंटल भी दिया है. पढ़ना दोबारा से जाके. है खुल्लर में कौन कौन सा दिया है? तीनों है ना? और भी दिया है कुछ? एक और मिलेगा आपको, दैट इज जो आपको कोई ना साइक्लोनिक रेन. कुछ कुछ बुक्स में जो मतलब जो गाइड वाइड टाइप बुक होता ना, देयर इज ऑल्सो दिस साइक्लोनिक रेन. साइक्लोनिक रेन कुछ होता ही नहीं है. राइट? साइक्लोन इज व्हाट इज साइक्लोन? साइक्लोन होता क्या है? साइक्लोन इज ए लो प्रेशर सेंटर where there is a winds are converging and then rising in the circulatory manner. So this convection is taking place in the cyclone. तभी तो इसको cyclogenesis बोला ना. So there is a convection process of the wind. Then the precipitation occurs. So there is no other fourth type of rainfall. This is only the 3. Right? Temperate cyclone में frontal rainfall हो रहा है. ट्रॉपिकल साइक्लोन में कन्वेक्शनल हो रहा है. When the winds have been obstructed by the mountains, they are called the orographic. सिंपल हो गया. और इसके अलावा कोई और रेनफॉल नहीं है. अगर कोई आपको बोलता है तो उसको बोल दोगे ये गलत है. There is no other 4 type of the rainfall. This is only 3: convectional, frontal and the orographic. There is no other 4 type of the precipitation has been observed. अच्छा, उसमें 2 चीज ध्यान रखना. One, it is types, another is forms of precipitation. Do not be confused with it. Types is convectional, orographic and frontal. Right? Forms are snowfall, sleet, hail, rain, drizzle. These are forms of the precipitation. Right? Don't be confused with it if it comes in the exam. Precipitation समझ में आ गया आपको? Saturation समझ में आ गया? Evaporation clear हो गया? Thereafter condensation also clear. Right? Snowfall is clear. Okay. Types of precipitation is clear. Right? It's clear or not? Clear, no? ठीक है, आज को व्हाट इज द डेट? 3 सितंबर है ना, टुडे इज 3 सितंबर ना, ठीक है. So we are going according to our plan. There is no change, no disturbance. Chaliye, okay. So these all are these forms of precipitation. Now, air masses. Air masses. The air mass is a volume of air which develop a volume of air or mass of air which develops on or which develops on the basis of certain atmospheric and physical condition. Physical conditions. Now then, the conditions for the development of an air mass. Conditions for development of an air mass. So these conditions are, number one, there should be homogeneous surface. Homogeneous surface means a uniform surface. Number two is no frequent change in atmosphere. No frequent change in atmosphere. Number three, it is no or absence of prevalence of wind. Number four, no thermal contrast. No thermal contrast. Right? Then after, number five, the strong conduction process. Strong conduction process. Number six is the adequate terrestrial radiation. Right? Here you can also write stable atmosphere. Stable atmosphere. So, on the basis of source or origin, air masses have been classified into different categories. Air masses have been classified into different categories. ये जरा मैप लगा सकते हो आप, इसको हैंग कर दो मैप को. We'll need map now. Thank you. So on the basis of origin or the source, the air masses has been classified into different types. So, air masses, the first it is called tropical air mass and polar air mass. Tropical air mass and polar air mass. So, tropical air mass and polar air mass, what will be the thermal condition of these two? What will be the thermal condition of these two? Huh? Temperature will be low in the polar region and the temperature will be high over the tropical areas, means, and also this has been classified again into two: tropical continental air mass, right? Tropical continental again classified into tropical continental warm, right? Then again tropical continental cold. Cold has been denoted by the K, right? Cold, tropical continental cold. Then after tropical continental warm, stable, and tropical continental warm, unstable. अब स्टेबिलिटी एंड इंस्टेबिलिटी ऑफ द एटमॉस्फेयर समझ में आ रहा है आपको? Stability and instability of the atmosphere. When there is no atmospheric disturbance, so what is that? Stable atmosphere. When the disturbance in the atmosphere develops, that is unstable, and the instability of the air also, right? This, as long as conduction process is continuous, so that will maintain the stable atmosphere. When the air current generate or the air current starts rising and it starts changing this thermal condition and the thundering and lightning starts, it means this is a atmospheric instability, right? So what is this condition is going on nowadays? What is the condition is going on nowadays in Delhi? Is it not stable? Right? It is uniformly, every day land has been heated. Every day there is no change in the temperature, uniformly temperature has been maintained. So there is a stability in the atmosphere has been prevailing. When there is some wind will be reaching in these areas and it will cause a precipitation, so there will be disturbance in the atmosphere. So that may cause the thundering, lightning and precipitation, or the dust storms, or the storms that will be responsible for instability in the atmosphere, or will make the atmosphere unstable. Clear? So, this is tropical maritime warm stable, tropical maritime warm unstable, right? Then again tropical continental cold stable, tropical continental cold unstable, right? Then after अभी देख लो इसको, tropical continental. Tropical continental, can we call this Sahara desert will have the tropical continental, Arabian desert, India Thar desert, Iranian desert, tropical continental, Kalahari desert, tropical continental, Australian desert, tropical continental. होगा नहीं होगा? Australia also, this is sorry, Brazil also tropical continental, right? All areas will have tropical continental air mass. North America also will have the tropical continental. So these areas will have the tropical continental air mass which has developed over the homogeneous surface. Am I clear? Sahara desert is it homogeneous or not? Complete hot desert. Kalahari Namib desert, complete hot desert. Australia, complete hot desert. तो किस टाइप का एयर मास बनेगा ये? Tropical continental warm? Yes or no? This all will be warm or not? Or not? This is tropical continental warm, 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 tropical continental warm. Correct or not? Right? Abhi, this is as long as it is on the continental masses, this will be stable or not? Over the continental masses, they are remained stable. They are remained stable. Correct or not? Right? Abhi kya hoga? They will become unstable or not? Yes, when they have been influenced by or pushed by winds. Which wind? Trade wind. When they will come under the effect of the trade wind, they will be displaced. देखो air mass में क्या होता है? When the air mass it develops, for example, this is warm surface or cold surface. Any situation, warm in the tropical areas, cold in the polar areas, right? Tri-Mediterranean circulation आपको याद है? When the wind has been subsiding from the atmosphere to surface, so this will be stable for the certain time. It will be cooled, and again this will be moving with the towards the polar areas, subpolar areas, right? Again, these winds have been moving towards the subtropical high to equatorial low. So this is a tropical warm. So this only for the certain time period, the air which has been resting there, so this heat will be transferred, or the cooling will be transferred to the air. So this air has developed cool. Again, or the warm, this will be transferred to the upper layer. So this has been warm. Again, there will be transfer of heat. So again has become warm. Again, there will be transfer of heat. So this will become a mass of air. So क्या बन गया? Air mass. Is it possible to develop this air mass in a one day? No. So there is a need of the process development for the transferring of the heat or the transferring of the cool in the air. So there is about 7 to 10 days period it develops in the development of an air mass. But here, if it is stable atmosphere, then only there will be stability in the atmosphere, or then only there will be their air mass will be developed. Clear? Right? So this air mass will be developed here in the over the surface. Right? So when this air mass has developed, now it will start coming in the effect of wind. Right? When this will come in the effect of wind, so this air mass will start moving. तो क्या बन जाएगा ये? Until it comes in the effect of the contrasting air mass. Contrasting means if it is warm, it should contact with the cold air mass. If it is cold, it should contact with the warm air mass. Then this disturbance in the atmosphere will create. That will be the instability. Clear हो गया? Right. So this is tropical continental warm is stable as long as it is remained on the continental part. It will become unstable and will reach there in the margins of the continent in the equatorial zone. तो क्या होगा? Here also this air masses will move to the ocean part. अब ocean में क्या है? Now we come on the second type of the air masses. Tropical maritime. Maritime means the air mass which has developed over the oceans. So tropical maritime air mass. Now see here. This is whole or entirely a tropical ocean. See everybody here on the map. This is entirely a tropical oceans except the equatorial zone. This is also entirely tropical oceans. Can we call them the tropical maritime? Is it not the tropical maritime? Is it not the tropical maritime? Is it not the tropical maritime? Tropical maritime. Tropical maritime. Right? This is also tropical maritime. Tropical maritime. Right? Here also tropical maritime. This is also tropical maritime. Right? Then tropical maritime warm. Tropical maritime warm tropical maritime cold, tropical maritime warm stable, tropical maritime warm unstable, tropical maritime cold stable, tropical maritime cold unstable. अब देखो tropical maritime warm, eastern part of the oceans, eastern part of the continent, in tropical areas we find warm ocean currents. So, वहां पे क्या होगा? tropical maritime warm, tropical maritime warm, tropical maritime warm, tropical maritime warm, here warm also, here also warm, Gulf Stream areas, Kuril current, Agulhas current, Mozambique current, East Brazilian current area, here is Southeast or the East Australian current. All are warm, so tropical maritime warm, right? Stable hoga, over this area it will be stable, right? Clear all? Again on this western part of the continents in the tropical, subtropical areas, cold current blows, tropical maritime cold, tropical maritime cold, tropical maritime cold, Canary current, California current, tropical maritime cold, here West Australian current, tropical maritime cold, right? अभी क्या हो गया देखो, this tropical continental warm, now they have been reaching over the coastal areas, right? Tropical continental warm, they have been reaching in the coastal areas. Which current is there? Which air mass is there? Tropical maritime cold. Different हो गया नहीं हो गया? So this tropical maritime warm will be pushing the tropical maritime cold towards the equatorial zone. तो क्या हो जाएगा? So both these air masses will become moist. This is warm and this is cold. So there will be transfer of heat in between each other. So they will be moving towards the equatorial zone. They will also become moist. So these tropical maritime warm, so they will reach to the coastal part of Australia. They will reach to eastern part of Brazil. They will reach to this, all air mass will reach to equatorial zone. As long as they reach in the equatorial zone, they will come in the process of convection and the vertical air current. So क्या हो गया? What will happen then? क्या होगा उससे बोलो? So then they will be converging and will rise up. So there will be disturbance and distortion in the air masses. So they will lose their characteristics of an air mass. While rising, the temperature will rapidly decrease and the atmospheric instability will prevail. So that will be responsible for distortion of an air mass. So air mass will completely destroy. Tropical maritime, tropical continental air mass will completely destroy. Right? अभी क्या हो रहा है? This air mass has reached in the equatorial zone. In the back over the source region, again the same conditions are prevailing. हो रहा है नहीं हो रहा है? When the same conditions are prevailing, so that विनय उसको नीचे बोलना जरा, सर को चाय दे दो. So when the source region, again its winds have converged over the equatorial zone, what is happening there back in the source region? Again the same condition is developing. What developing? Again this air has been heated. There again the vacuum space is formed. Again the air has been heated. Again the same air mass is developed. So this is again the flow of the air mass in the equatorial zone. So this cycle continues every day, right? And this over a period of time, this air mass develops and move towards the convergence and then distortion it happens. So their air mass will change or will lose its characteristics. Clear? चलिए polar region में आ जाइए. Same condition will be there. Polar continental. this is polar continental, then polar continental warm, polar continental cold, polar continental warm stable, polar continental warm unstable, then polar continental cold stable, polar continental cold unstable. Polar continental Canada, polar continental cold, polar continental cold, Siberia, polar continental cold, northern part of Europe, polar continental cold, Antarctica, polar continental cold. होगा नहीं होगा? समझ में आ गया? Right? Polar continental cold. Now here there is again this condition here. They are polar maritime cold and polar maritime, then after polar maritime warm, polar maritime cold. अब ये पोलर मैरीटाइम कौन सा हो गया? लैब्राडोर ओशियंस, पोलर मैरीटाइम, polar maritime, this is polar maritime, this is here polar maritime, this is here polar maritime, this is polar maritime, right? Clear? Then after polar maritime warm. अब this warm ocean current is reaching there in the polar areas, so they will make the ocean warm or not. So this is polar maritime warm, right? Alaska current, polar maritime warm, it is also warm, right? So this is polar maritime warm. Polar maritime cold, Labrador current, Ohio current, polar maritime cold. This circumference of west wind current, polar maritime cold, circumantarctic current, west wind current, they are polar maritime cold. Clear? अभी यहाँ पे क्या हो रहा है? Polar maritime warm is meeting to the polar maritime cold. तो क्या बनेगा यहाँ पर? There will be warm and cold air masses again will be mixing where? They will mix in the margin of continents, right? There will be margin of continents at the margin of eastern part of North America, western part of Europe, right? Eastern part of Japan, right? And the western part of Canada, southern part of Chile, southern part of New Zealand. So there will be confluence of the two different air masses. One is cold, one is warm. So warm will try to push the cold, cold will try to push the warm. So there will be again the mixing of two air masses, the same mechanism. So then after, because of this mechanism, so this warm will be areas of the development of low pressure, right? And the cold will be areas of the development of high pressure. So there will be confluence of warm and cold. So there will be formation of front. So warm will be entering in the areas of cold, cold will be entering in the areas of warm. So there the front will be formed, right? And this stage will come when the warm will be mixing in the areas of cold, cold will be mixing in the areas of warm, and then the stability will prevail. The air will become क्या हो जाएगा? Disturb हो जाएगा? नहीं होगा. Mixing, at the time of mixing, so there will be atmospheric disturbance, atmospheric instability will prevail. Then because of this atmospheric instability, the disturbance, thundering, lightning and heavy precipitation will occur, right? Where it will happen? Where it will happen? कहाँ होगा? Which region in the world, on the globe? Which region in the globe? Temperate zone. So क्या बन रहा है वहां पर? Cyclone हो रहा है, right? So that is called the temperate cyclone, right? So that is the zone of the two different air masses, cold and warm air masses is the zone of low pressure center. So there is a temperate cyclone. Temperate cyclone. Temperate cyclone is also called extra tropical cyclone, right? Extra tropical cyclone. It is also called mid latitude cyclone. Right? Mid latitude cyclone. Clear? Okay. Then after अभी इसमें देखो जरा. Here on the sea surface, the temperature is 27 degrees Celsius or more. Right? तो क्या हो गया इसमें? Because of high temperature, their low pressure center has developed. Right? So this low pressure center will be responsible for convergence of wind. When the wind has been converging from all the direction, so what will happen? So they will converge and rise up. So when their strong convection will take place, when the strong convection is happening, they will lift the wind very strongly and will also lift the upper layer of the water. So that here this rising happens in the funnel shape and there will be vortex will be formed in the circulatory motion of the water. So क्या हो गया ये? This is the cyclone which develops between 10 degree to 35 degree latitudes in both the hemisphere. What is this region? Tropical region. Sea surface temperature is similar to the tropical region. Is it not the 35 degree latitude in the subtropical region? But the sea surface temperature is similar to the tropical region. So this is called the tropical cyclone. So this is a tropical cyclone. Up here the temperature is more. So the pressure is excessively low. So the pressure gradient force will be high or low? Pressure gradient force will be high or low? Definitely it will be high. So if the pressure gradient force is high, wind velocity will be high or low? It will be high or low? High, because pressure gradient force is high. So that is the pressure gradient force is high. So that wind velocity also will be high. If the wind velocity is high, so it will be beyond the sustenance capacity of the coastal areas. तो क्या बन गया साइक्लोन? Destructive हो गया. Yes or no? The cyclone has become destructive. अब यहाँ क्या हो रहा है देखो? See the comparison. In this region, in the temperate areas, so there is the warm air is reaching to the cold areas, cold air is reaching to the warm areas. So their low pressure is because of, is it thermally induced or not? Low pressure is thermally induced or not in the temperate zone? Yes or no? No. कैसे होगा thermally? Thermal induced मतलब क्या हो गया? Heating of the surface of the land or the sea, right? But here this low pressure is not because this subpolar zone. This surface is not heated because of the heating. Here the low pressure is because the warm air is reaching there in this subpolar zone, temperate zone. So this is low pressure is dynamically induced. So this cyclone, temperate cyclone is dynamically induced, and tropical cyclone is, because of surface temperature, it is thermally induced. So when thermally induced, so means sea surface temperature will be more and the wind velocity will be very, very high. Okay. I'll take 5 minutes break. So, this tropical cyclone is thermally induced and temperate cyclone is dynamically induced. When this is dynamically induced, it will be destructive or not? Temperate cyclone will be destructive or not? No. Why? Temperature is not the factor for the origin of cyclone. So, therefore, the pressure gradient force also will be low. So, the cyclone will not be destructive. So, when the pressure gradient force is low, wind velocity will be low. So, there the wind velocity has been recorded about 50 to 80 kilometer, so 50 to 80 kilometer per hour, or maximum it reaches to the 100 to 120 kilometer per hour, not more than this. But here wind velocity कितना होता है? Average is 150 kilometer per hour. And if it is more than 150 kilometer, or it goes beyond the 180 kilometer, this is called the super cyclone. अभी बिपर जो आया था गुजरात में, what was wind velocity? The wind velocity reached to the 150 kilometer per hour, and the meteorologist said if it is the wind velocity will cross the 150 kilometer per hour, it will be declared as a super cyclone, right? But there in the case of hurricane, so there are the different names of the cyclones. There are different names of tropical cyclones. Different names of tropical cyclone. This is called Willy Willy in Australia. It is called Taifu. Taifu it is called no. Taifu it is called in the Taiwan. Typhoon, South China Sea, Philippines and China. It is called tornado, Japan. Hurricane, USA, right? USA. And cyclone in Indian Ocean, India and Africa, right? These are the names of cyclone. But there the wind velocity in the hurricane and tornado, this goes beyond the 200 to 250 kilometer per hour. And this is a new research in the recent time, and अभी परसों ही आया है, World Meteorological Organization का एक report आया है. Yesterday only I have read that report. World Meteorological Department they are saying, because of temperature rise of the oceans under the effect of climate change, the intensity and frequency of frequency of tropical cyclone will increase. So that because of this rise in the tropical, because of intensity and frequency in the tropical cyclone, the wind velocity in the hurricane will cross more than 280 km per hour. Right? Now presently it has been recorded about 150 miles per hour, and they are saying this will touch to about 180 miles per hour to 200 miles per hour. So that high wind velocity will be reaching. मतलब क्या हो गया? So intensity of the cyclone will increase and tropical cyclone will become more destructive. Correct or not? We have seen this in the case of India also. So uniquely or surprisingly, this year in 2023, sea surface temperature was more than the average over the Arabian Sea. Reason for? It was the temperature recorded about 32 degrees Celsius over the Arabian Sea. So this region of this high temperature, so there has been the origin of cyclone. Otherwise, in the summer season, cyclone does not occur in Arabian Sea. उसका impact देखो क्या हुआ? What was the impact of that cyclone? Impact of cyclone was the wind which was supposed to reach over the India. These all winds have converged in the cyclone system. This monsoon has reached late in the peninsula. Why? Because wind which was supposed to reach from the Arabian Sea to the west coast of India, so this all wind has diverged towards the cyclone system, low pressure system. So there this has made the cyclone more stronger. So there has been the less rainfall, right, over the peninsula. Number two, their cyclone has entered in India from the western part of Aravalli. देखा the track, the cyclone track is from the western part of Aravalli, means western part of Aravalli desert area has received the precipitation this year, excessive precipitation. It entered from the Kutch to the Jaisalmer and to the Barmer, Jaisalmer, then it has entered into the Delhi and the Punjab. Then also precipitated before the monsoon time. The date of the monsoon arrival in the Delhi is 29 June, but the rainfall is started 25th June itself. For northern part, it has been responsible for the early rainfall, but this is southern part, there has been delayed in the monsoon. And this rainfall in the month of July, it has been above than the average. Right? This on the 31st this August, IMD has said this August month has received 9% less rainfall of this month. Right? Reason for that, more the excessive rainfall which has occurred in the month of July because of tropical cyclone, that Biparjoy, has reduced the precipitation here in this month of August. Clear or not? So this is the mechanism which has been responsible for change. This is the result of climate change. अभी बारिश नहीं हुआ अगस्त में, तो यहाँ पर हुआ नहीं हुआ, नहीं बारिश ही नहीं हुआ इसमें, तो whole August has been almost dry. Right? The rainfall has happened in the month of June or July only. August has been completely dry. Reason for there was excessive precipitation in the July in the effect of Biparjoy or the tropical cyclone in India. And also tropical cyclone has become weak there in the Bay of Bengal. So this area is under the effect of climate change. These cyclones are becoming more stronger and wind destructive. The wind velocity was 150 km per hour in the Biparjoy cyclone. Right? Clear हो गया आपको? So this is also called a tropical cyclone and the extratropical cyclone. Right? Precipitation आपको हो गया, evaporation हो गया, condensation हो गया, types of rainfall and all. Right? अभी आपको मैंने एक मैप दिया, वो इस टॉपिक में इसमें इंक्लूड नहीं है टॉपिक, that is important. I have given you map of climate classification. So there is climate type लिखा है कहीं पर, तो नहीं है. चलिए, अच्छा एक बार आप ये देख लीजिए क्लाउड फॉर्मेशन एंड टाइप. क्लाउड फॉर्मेशन देखो कैसे होता है. देयर इज ए लो प्रेशर सेंटर, wind is the air current rises, and this air current which has moisture or the air is moist. Right? यहाँ पे क्लाउड फॉर्मेशन और इसको टाइप्स भी ऐसे बता देते हैं. राइट? देयर इज the current formation or the ascending of current and the width of the moist air. So this air when it is rising or in the process of convection, when it reaches to its point of the saturation or the point of the molecules of the moisture, it condenses. That is called the line of condensation. Line of condensation. Line of condensation means there is a rising of air and humidity. Humidity, you understand the concept of humidity? Humidity means presence of moisture in a given parcel of air, over the space and the time. Means The humidity is amount of moisture or vapor present in air. That is called humidity. So humidity has been classified into one, relative humidity, and absolute humidity. Relative humidity and the absolute humidity. Humidity is relative humidity is dependent on the temperature of air. Means higher the temperature, higher the capacity of holding the moisture. Relative humidity means capacity of holding moisture of air. Moisture of air. So means higher the temperature, higher the capacity of holding the moisture. In the areas, for example, the areas have the 50 degree Celsius temperature and the another area has the temperature is about 30 degrees Celsius temperature. So this more of the high temperature areas or the air will have the more capacity to hold moisture, because molecular distance in the air will be more warmer, more lighter on the air A. Air B, their molecular distance in the air will be less, so its moisture holding capacity will be relatively lesser in comparison to the air A. So on the basis of the temperature, the air has the moisture holding capacity. That is called relative humidity, right? So in high temperature areas, relative humidity will be high or low? Relative humidity, the presence of moisture in the air will be high or low? Presence in the moisture will be less. In the high temperature areas, presence of the moisture will be less, but the holding capacity will be more. For example, in these areas, the air is having only the 10% of moisture. But take example is 20% of moisture, and also it has a 20% of moisture of its whole capacity. It will rise up. Both are warm. This is warm and moist, and this is only warm, not moist. So this will rise up in the atmosphere. Temperature will decrease. Temperature will decrease at what rate? Wet adiabatic rate, because the air is moist. Wet adiabatic lapse rate. Right? Here the temperature will decrease with the dry adiabatic lapse rate. Right? So then after it will become here, there it will be 30%. Relative humidity will become 30%. Here will become 40%. Here the air will have, or it will become the 80%. Then it will be about 60% or the 50%. Here the air will reach to the 100% humidity, and here the air will be 70%. Right? अभी क्या हुआ यहाँ पर? There the air has reached to the 100% humidity, means the moisture holding capacity and the amount of moisture is same. समझ में आ गया? Moisture holding capacity and the amount of moisture in the air is same. तो क्या हो गया? This is absolute humidity. Right? Moisture holding capacity and the amount of moisture in the air reach to the absolute humidity. Right? Now the air has been pushed to rise beyond the point. This is the point, this is the line of condensation. At this absolute humidity, the molecules or the vapor will start condensing or colliding with each other. There is a formation of cloud. So this is called the condensation. Here is a condensation. Right, there is a condensation. Clear? And when this condensation it happens, so this is air reaches to its the point of absolute humidity. When the air has been reaching there up, so there is a line of saturation. There is a line of saturation. Line of saturation means there the absolute humidity has been attained by the air. Means beyond that the air does not have the capacity to hold the moisture. Right? Again the air has been forced up to lift due to strong convection. Then what will happen? The humidity will be 110%. Right? Humidity will be 110%. So what will happen? So it will precipitate. कितना करेगा ये? 10% moisture will be shed down in the form of convectional rain. Right? It means the presence of moisture determines the height of condensation. Clear हो गया? It means in the dry adiabatic rate, the condensation will take place in the higher altitude. Or the air will get saturated at the higher altitude. कभी भी आप देखोगे desert areas में, so there the clouds are in the patches. They are not, we will not find the dense cloud in the desert areas. Reason for the convection which is taking place in the desert areas, they have least or no moisture. And there are patches of clouds. So these clouds are high altitudinal clouds. Clear? So there the saturation and condensation is at the higher altitude. And then when the air is reaching to the plus of absolute humidity or beyond the saturation point, drizzling will happen. Why? Because the presence of moisture in the air is very less. When drizzling it happens, there will be what? Re-evaporation because of surface temperature is more, or that amount of the precipitation is not sufficient to meet the demand of the water bodies on the surface. So then permanently dry condition will prevail. But here what will happen? There will be heavy precipitation and the water contribution will be greater. Right? So this is the precipitation, means the moisture content in the air is responsible for the formation of clouds. अभी देखो, the clouds has been classified into three types. Up to 2 km, this is called lower cloud. Up to 6 km, it is called medium cloud. Up to 12 km, it is called high cloud. Right? Medium cloud, low or the low cloud, low clouds, medium clouds and the high clouds. There is cumulus clouds, which is having the cotton shape. That is called these are the low clouds. And also when this cumulus clouds are in the horizontal manner, this is called stratocumulus. Strato means what? Strato means horizontal cloud. Strato means horizontal cloud, horizontal expansion. Stratocumulus cloud. Right? And then after, medium clouds are when there is a flat base and cotton shape. Flat base and cotton shape. There is a halo effect. They cast shadow on the surface because of halo effect. This is called the alto cloud. Right? So this is alto cumulus. Alto stratus clouds are there. Alto cumulus and alto stratus. Right? When the clouds with a very less moisture in the scattered state, this is called cirrus clouds. Right? Cirrus clouds. Okay? When these cirrus clouds are in the, or the high altitudinal clouds in the cotton shape or the cotton balls, क्या हो गई? Cirrocumulus. This is cirrocumulus. Right? And when this cirrus clouds are in the horizontal expansion, this is called cirrostratus. Cirrostratus. Right? There is also the moisture containing clouds are called nimbus cloud. Moisture containing clouds are called the nimbus cloud. Right? अभी देखो इसमें because of strong convection from surface to atmosphere, there will be formation of cloud, which has flat base and the vertical formation. Flat base, cotton shape vertical formation is the result of strong vertical ascending of wind, air. So that is responsible for what is the shape? Cumulus. So this cloud has the presence of moisture. So there will be different layers of clouds. So this lower layer of the clouds has the strong convection, or it is also called convection layer or convective layer. The lower layer it is called the convective layer. Middle layer it is called the mixing layer. Mixing layer means what? Mixing layer is the rising or ascending warm air and descending the moisture or the water droplets down towards the surface. So then this is the mixing layer, this is downward and this is the upward movement, right? तो इसमें देखो कैसे precipitation होता है. The upper layer has ice crystals, which is there in the high altitude. So this will have the ice crystals. Middle layer will have water droplets. Okay. अभी देखो अभी कैसे precipitation होता है. In the process of convection, see everybody here. In the process of convection, the moisture has been lifted up. It has reached to the middle layer of the cloud. And because of strong convection, this moisture has been further lifted up to the higher altitude. तो क्या बन जाएगा ये? Ice crystals. So this ice crystals will be heavier in the formation. So they will become heavier, so they will fall down, right? But there is again the strong convection is there. So this has been lifting up there in the atmosphere, in the upper layer, right? So then the size of ice crystal increases. And this has been strong convection. When there is a continuous supply of the air and the strong convection is making the holding the moisture for the longer time. And then more of this convection, when this whole layer of the cloud has been saturated with the air, then the precipitation occurs. क्या होता है उसमें? Sleet and hail. जिसको हम बोलते हैं ओला. Ola is what? Ola is the falling of the ice crystals. The Ola formation or the hail formation will be only in the condition when there has been the strong convection and convection has been for the long period of time, right? If the strong convection is there but not for the long period of time, then what will happen? The air will lift and it will lift the moisture upward, the air will be saturated and it will fall in the form of rain. There will be torrential rain. But when there is a strong convection for the long period of time, there will be decrease in the temperature of the surface because it has been covered by the cloud. So insulation will be decreased. So there will be continuous, there will be cooling of the surface and the ice crystals will be falling down on the surface in the form of the solid state. Otherwise, the convection is not so strong, the ice crystals will fall on the surface and they will melt. Reaching there, near the surface, they will fall in the form of the rain or the water droplets. Right? When there will be strong convection, then only there will be the hail formation or the hail occurrence in the different areas on the surface. कभी-कभी monsoon time पे भी होता है ना, rainfall, hail precipitation. Right? This is because of when the strong convection has happened. But on the other areas, when there has been the continuous rainfall and the strong convection has not developed, then there will be heavy rain. So what will be what type of rain will occur here? Convectional rain in the form of torrential. So here will be torrential rain. So this is cumulonimbus cloud. So this cloud is called cumulonimbus, or it also can be called as nimbocumulus. Nimbocumulus means wherever their nimbus cloud will be there, nimbus cloud is always a rain bearing. Means where the nimbus cloud is there, definitely there will be rain bearing or the rainfall will occur. And nimbus cloud is always there in the dark color. So this cloud will be there in dark gray to black. आसमान एकदम बिल्कुल काला हो जाता है. The insolation has been completely trapped within the cloud. It covers the sky. So this insolation does not reach on the surface. There is sudden decrease in temperature because of this cloud cover. And this cloud cover, this decrease in temperature is because of this thickness of the cloud. So it does not allow to penetrate the sunlight, and there is the complete dark it occurs, and there is a heavy precipitation for the long period of time. This is from the dark gray to the black, means dark gray to black means this is a presence of moisture or the volume of moisture in the air. हम बोलते हैं ना आज बहुत तेज बारिश आएगा with the visibility of the cloud, right? And sometime it also happens there is the complete larger area is under the rain, but rain is not torrential, rain is very light and mild, but the rain occurs for the long period of time. कभी कभी होता ना पूरा दिन बारिश हो रहा है, the whole day is in the rain, right? But rain is not so heavy and torrential. It is very mild and but it is continuously occurring for the whole day, right? So this rainfall occurs because of stratonimbus cloud. Nimbus is rain bearing, and then horizontal coverage of the area. So that is because of stratonimbus cloud, right? Cumulonimbus cloud, there the rainfall occurs in the equatorial region, लिख लो इसको, equatorial region, tropical and subtropical areas. Cumulonimbus cloud, rainfall occurs in the equatorial region, tropical and subtropical areas. Okay, and stratonimbus cloud, the rainfall occurs in the temperate zone, in the frontal rain, because of horizontal mixing of warm and cold air mass along warm sector. Warm sector में क्या होगा देखो, there in these areas, this is front is formed, here is a horizontal mixing of warm and cold. So this is warm sector. So here is the vertical mixing, so there is stratonimbus cloud. Stratonimbus cloud. From here, the cold air is reaching there in the warm sector. So here the cold air will be lifted up vertically. So there is a cumulonimbus cloud. Right? Here the rainfall in the stratonimbus areas or the warm sector, their rainfall is long duration. Long duration कहाँ पर होगा ये? In the eastern margins of the continent in tropical and in the temperate zone, not tropical. In the eastern margins of the continent in the temperate zone. Western margins of the continents there will be a rainfall, but this will be in the intervals. As rainfall will occur, and then again it will stop. Again the rainfall will occur. Right? बारिश होता ना इसमें क्या बोलते हैं? When you see the match in England, anytime rainfall occurs. Anytime means when there will be mixing, the rainfall will occur again. This air, the warm air will be lifted up. The stability will prevail. Again, there will be mixing of the air. Again, the rainfall will occur. But this is not very heavy and then torrential. This is convectional but mild. So temperate cyclone does not have the torrential rain. Tropical cyclone has torrential rain. Tropical cyclone में क्या cloud बनेगा? In tropical cyclone, what will be the cloud? Cumulonimbus cloud, where because of vertical convection and the latent heat will be high there, right? In the tropical areas, so the moisture supply in the air will be maximum. So therefore, vertical rising or the vertical rising of the air also will be strong. So when this vertical rising of the air will be strong, there will be strong cyclone, right? In tropical areas, rainfall will be torrential, heavy precipitation, right? Heavy precipitation, and then that will be destructive, right? In the short duration. In temperate zone, there is a gradual mixing of the warm and cold air mass. So the gradual mixing means rainfall will be for the long duration in the intervals with the stratonimbus cloud, and that rainfall will not be destructive at all. Rather, that rainfall is very much good or beneficial for the rabi crops in the temperate areas. And there the rainfall there in tropical areas it is responsible for coastal flooding. Sudden rainfall, torrential rain is responsible for the coastal flooding. समझ में आ गया आप लोग? Clear हो गया? Right. So this is the cloud formation, and then after they are in the different part of the world. In the western part of the continents, there will be stratonimbus cloud, right? Or there at the margin of convergence of the cold and warm air masses, there will be strong lifting of the air, convection. Eastern margins of the continents in the temperate zone, there will be stratonimbus cloud. Clear, right? So there in the eastern part of North America, which cloud will be formed? Eastern part of North America, stratonimbus. Western part of North America, cumulus. Western part of Europe, cumulus. Eastern part of Europe, stratonimbus. So there in the areas of this stratonimbus cloud is favorable for the temperate crops, rabi, wheat. So eastern part of Europe is rich ground for the temperate crops, temperate grasslands. Like temperate grasslands को क्या बोलते हैं? They are the names of the temperate grasslands. Temperate grasslands are this is called prairies in North America. This is called pampas in Argentina. This is called veld. This is called veld in South Africa. This is called downs in Australia. It is called pustas in Hungarian plains, right? And these are called marg in Jammu and Kashmir and Bugyal in Uttarakhand. Have you heard of this Sonmarg, Gulmarg? Sonmarg, Gulmarg. These are the marg grassland, temperate grasslands in India, right? These are the temperate grasslands in different, and this is also another one is there, Canterbury. It is called Canterbury in New Zealand. In the New Zealand, these are the names of grasslands. Tropical grasslands. Tropical grasslands, this is called Llanos in Venezuela. This is called Campos and Caatinga in Brazil. This is called savanna in Africa, India and Australia. These are the tropical grasslands. Okay. So temperate grasslands are nutritious and the favorable condition for the wheat and the many other crops, right? So okay, I am leaving this word climate here, climatic region, what you have, right? Because we have already one topic on the session 7, Okay, world climate and biogeography. So we'll take it there, this part. Again, we'll repeat the climate. Okay. Then next session we'll have oceanography. Oceanography. We'll have again this next session. Then after we'll have the world climate and biogeography. Okay, we'll take this. You keep this map with you. This is a very important map, and this is not there in the any of the atlas. So this I have this very old atlas was there. This is not published now. So I have given it. So keep this atlas with you, and when we will have next class, you bring it with you. Okay, you paste it and fix it then in your notebook. So it will be intact with you. Okay, so we'll meet in the next session. Thank you so much.